Hello, Miss Rittenberry. I received your question. You mentioned just working some problems. I thought I'd try this as a sample problem. If you could specify which problems you'd like me to work at would be helpful. Okay, on this particular problem here, it's 4.1, number 4, that I have here. It asked, given the quadratic function standard form, address the following questions. So here's the equation, and there's quite a list of questions, and I see that you missed several of them. Okay. I guess, what's the standard form of a quadratic equation? Well, it's f of x equal to a times quantity x minus h, closed quantity squared, plus k. And they have this in the book, if you look it up. This is the general form. And this, when you have it in this form, standard form, it tells you many things. The first item, what's the vertex? Well, the vertex, when it's in this form, is hk. Okay, and where did that come from? Well, if you look what's in the parentheses, you got x minus h. And whatever number's here will be the x-coordinate of the vertex, and the number out here will be the y-coordinate. Now, one thing you need to keep in mind, this is x minus h, and so the x-coordinate, you're always going to change the sign, or when it's in parentheses, you're going to change the sign. So if you come over this particular problem, it's got x minus 3, and so the vertex will be 3, and then negative 1 for this particular problem, which is what they show you here. Okay. So the vertex for this one again is 3, negative 1. If it's in parentheses, you always change its sign, and then you maintain the sign that's outside. Next question, does the graph open up or down? Well, the A determines whether it opens up or down. You might look at this example and say, well, there's not a number in front of the parentheses. Well, if there's not a number there, it's understood to be positive 1. And so for this particular problem here, A is understood to be 1. And so does it open up or down? Well, if A is positive, it opens up. If A were negative, it opened down. And so in this particular instance, it's positive, so it opens up as opposed to down. Then it asks, what's the axis of symmetry? Well, the axis of symmetry will be always x equal, and whatever the x-coordinate is up here, the vertex. And so that's where the x equals 3 comes in, is, that's the coordinate right there. If I start to draw a picture here, the vertex is 3, negative 1, and this is, it's opening up, so it's opening up, and the axis of symmetry, I'll draw in red, the axis of symmetry is a vertical line going through the vertex, x equal 3. Okay. Next question here is, find any intercept, the x-intercepts. Well, to find the x-intercepts, you're going to have to set this, let y be 0, or set this equal to 0. Okay, and I probably don't need a little more space to work that out. So I'm moving this up here some, and give myself a little space down here. And so we have the equation up there. I need to set this equal to 0. So I want to find the x-intercepts. So let the y value be 0, or f of x be 0. Many ways you might solve this, but the easiest way would be to add 1 to each side and apply the square root property. So 1 would equal quantity x minus 3, closed quantity square. Use the square root property. You have to let me know whether you're familiar with that. And square root of 1 is just 1. And so if I come over here, it'd be x minus 3 equals 1, or x minus 3 equals negative 1. So if I add 3 to both sides, I'll get x equals 4, or x equals 2. And so that's where it crosses the x-axis, is at 2 and at 4. I can't see it very well, but it shows 2 or 4 here. The next part, I've got it up here on the screen. The next part asks for the y-intercepts, where it crosses the y-axis, if I keep going here. Well, to find out where it crosses the y-axis, instead of letting y be 0, you let x be 0. So I need to go up there. If I move this up a little bit further, I'm going to lose the graph there, but so I have the equation. I want to let x be 0. So I want to find f of 0. So I replace the x with 0. So it'll be 0 minus 3, close point, squared minus 1. So that'll be 9 minus 1, or 8. So I'll cross the x-axis. Oops. So I'll cross the x-axis, the y-axis, sorry, at 8. So so I'll cross the y-axis at 8, and so I just put 0 in here for x. Hope this is not too messy. Then you have to pick out the correct graph. Well, I've graphed it over here. And you also have to state the domain and range. Well, the domain is the same on all of these. Domain is all real numbers. They go left and right forever. The range will vary. You pick out the smallest y value, in this case when it's opening up, and you can pull that from the vertex. The smallest y value, remember, was -1. So the range would be the open interval from -1 to positive infinity. I hope this helps.